So there has to be a way to represent a certain object. So for example, if I want to define a surface of a, if I want to define some surface, how will I do that? I would need to define curves and all that on the surface to define it properly. So the most popular thing in computer graphics is called meshes. So what you do is you specify points on a body and you connect those points using edges, forming polygons such as triangles. So as an example, if you look at this teapot, so this part of the teapot, if you see, it is connected of small wires and small points and edges, right? So you can see like this is like one triangle, other triangle, and these are all connected to each other. So this is what you call a mesh. So mesh is a collection of vertices and edges, and this is you can use it to define any object. So for example, this here, a rabbit or a bunny, you can define it using these vertices and edges. So pretty much any object, any of a very arbitrary shape or a very different shape, you can always define using it. And you probably would need more samples to better capture the complex geometry. So for example, if you look at this hand, so this hand, the leftmost image, it has like 25,000 vertices. So that's why you can see the hand, it really looks like a real human hand. And now the second picture, it uses 5,000 vertices. So now you can see that the geometry has become more simplified, and you can easily spot out the triangles and the edges. And the last image, it only uses 500 vertices. So now you can clearly see that there is there are sharp edges, and the hand geometry is not as well captured as the leftmost image. So there is always a trade-off. If you work with a lot of vertices, then you would run out into computational problems because you need to store all this data and you need to process all this. So it can take time to process such data. And this one, it is almost 500 times less data than the leftmost image, right? So it is easier to process this, easier to store this, but you can see that it does not capture the geometry very well as the leftmost. So there is always a trade-off like this in computer graphics. So there are many other ways to represent a shape. So one way is to represent a shape implicitly. What does that mean? So you can define a function that defines a surface. So for example, if I want to tell you that I have a sphere, the sphere can be completely defined by its center and its radius or diameter, right? So if you use a mesh, what you would do is you would define points on the surface of sphere and connect them using edges. So it won't be a perfect sphere because otherwise you will need infinite points. But in this case, because sphere is a very simple shape, so you can always define it using a function that given a center and given a radius, I can always define the boundary of a sphere, right? And then there is something called constructive solid geometry. So if you are able to define simple primitives like sphere, cylinder, you want to define more complex shapes. So what you do is you must have learned about sets in your high school or in different class, right? That you do union operation, you do intersections and all those. So you can do, so constructive solid geometry uses similar concepts. So for example, the shape on the top, if you want to define it, there is no easy way of defining directly like a circle or a rectangle, right? But what you can do is you can define a circle and the rectangle. And you can say that if I overlap this rectangle with the circle, the part that overlaps, I will take that out. I will subtract that. So this is one set operation that you perform using two simple objects and you generate one complex object. Until now?
Yeah. Yeah, I think it's fine. Yeah, go ahead.
Okay. And then there is a next thing called sweeping. So what does that mean? So for example, if you have a circular ring in your hand, and if you move that ring in a straight line, so what you will get is that it will produce a cylinder, right? That a circular ring moving in a straight line will produce a cylinder. So you can do, like you can move the ring in a circular fashion and it will produce a torus. And that's what we call sweeping. And then there are other methods such as octrees. in which you can use small cubes to define a shape of an object. So now let us see what does illumination and rendering is all about. So like I talked earlier, this is a process of defining light in the scene and generating images capturing the real world phenomena. But it is not necessary to restrict to the real world. You can always create some hypothetical or imaginary objects or imaginary lighting and generate some images. So first question is, we want to answer, where and how much light is there in the scene? So which means that if you treat the light, if you talk about light rays, so from where do they start in the scene and in what direction do they follow? Then the question is, how do these objects reflect the light? So those light rays will hit the objects, right? And these objects will reflect the light. So for example, that's how you see things, that some light reflects on an object, and that's how you see an object. And that's what we want to capture. So surface properties can be shiny or diffuse, which does not give very shininess. So we can have very different types of surfaces. And then you can talk about, okay, now the lights have hit this, now the objects are reflecting the light rays. And if the light rays hit your eye, that's what you will see, that particular object you will see. So you want to see that which reflected light rays which will hit our eye, or the image, or the virtual camera that we are simulating. So rays get reflected a lot in the scene, and there can be occlusion. So for example, if there is something behind a desk, you will not see it because the desk is in front of it, and all the light that is reflected from that object will not come to your eye, and that's why you won't see that object. So appearance of the objects depends on the viewing direction and the light direction. So for example, if you are in a room, and if you move around in a room from one place to the another, you will see different lighting conditions and you will see different appearance of objects, right? So this is what I mean by that. Okay, so this is a chart illustration showing that how can, like, what kind of different properties that we have. So for example, if you go on this vertical axis, you will see that the object is very diffusely reflecting light. It looks like a very matte finish thing. But if you go in this direction, you will see that there is some highlight, which is like more like a mirror kind of a highlight, right? That if something is shining, it will directly shine on your eye. And this is what we call specularity, and this is what we call diffuse. So objects can have mixed nature and probably more different kind of properties. So let's talk about this first image. So the big arrow shows that the light is falling onto the surface, and all these small arrows show that how the light is reflected. So for diffuse surface, what we try to model is that from wherever the light is reflected, it will get reflected in all the directions. That is how you generate this image. And then this image means that if the light is coming in this direction, so these are the rays that will get reflected out of it. So if you are sitting somewhere here, you can see my mouse pointer, right?
Yeah, we can see that.
If you are viewing from here, then you can see this particular point. But if you are here, you won't be able to see this point. Okay. And this is like a pure mirror kind of reflection. A ray comes in here and it gets exactly reflected like this. So this is what you must have learned in your physics in your 11th class, how the light can get reflected. And this is called refraction. Like for example, transparent objects or translucent objects. The light can go through that object. So this is exactly the same process. Now the light is going through the object. So you can model like transparent objects or opaque objects like that. Then there is the next step is like, okay, you can light all the objects in the scene, but given the viewer or given your virtual camera, you want to determine that which objects are visible and which objects are not. So let's look at this top-down scene.